Hi everyone, today we're talking about functions, domain, range, and of course function notation. So first off, we define our domain. It is the first set of the function, like we talked about yesterday. It's defined as the set of all possible x values. So I would highlight that information. You most likely talked about this in Algebra 2, so it's just the set of all your x values that work in that function. It is the independent variable, and it can also be called, there's a couple of different names you're going to hear. It could be the elements of the domain, the x values, the input values. If you see any of those words, you're talking about domain. As opposed to range, it's just the second set of the function. So its formal definition is the set of all the possible y values. It is also the dependent variable, and it has a few names called the elements of the range, the y values, the output values, and one that you have to pay special attention in IB. They call it the images of x. So if you were to draw a mapping like we did yesterday, you've got your domain on the left bubble, and then you've got range on the bubble to the right. And let's just say you've got 1, you've got 2, you've got 3 as your possible x values. And then your range would be 5, I don't know, 6, whatever numbers you really want, 7. And then you could draw a mapping out of that. And what it would look like in a t-chart, so those are all one-to-one. In a t-chart, you could see your x values on the left column and the y values on the right column. So you would have like 1, 2, 3, and then you would have your 5, 6, 7, and these would be coordinates. So you could call, if I asked you for what the domain of this t-chart is, you would just circle all of these numbers, all your x values. So domain. And then if I asked you for your range, you would be looking for all your y values, and that would be 5, 6, 7, range. A few examples. You could consider the function y equals x squared. And if it asks you to find the image, you're looking for the corresponding y value given an x value. So for our first little part A, if x was equal to 1, all you would do is just plug in 1 and figure out your corresponding y value. And that is called the image of x. So your answer would be y is equal to 1. If you had x value of -2, same story, you just plug it in. So -2 squared would just be your 4. So y is equal to 4. And those are part of your range. So if we wanted to state the domain and range of this function, you kind of have to know what a y equals x squared looks like. If you remember way back in Algebra 2, the graph of it would just look like a parabola facing upward. So you're going to notice that that parabola, the lowest it goes, has a y value of 0, and it really doesn't matter what x values you plug in to y equals x squared, right? So I kind of look at our, let me get a different color, our domain as all the possible x values that you could plug into that function. And you're going to see if you had an x value of something over here, you're going to have a corresponding y value that is above the x-axis. Same story at 0. That function is defined at 0. And actually for any x value to the left of 0 and also to the right of 0, you're going to have a corresponding y value. So really your domain is all real numbers. You can plug in any real number into that function and you will have a corresponding y value coming back. All real numbers. Now for your range, though, you're going to look at all the y values. And what you notice, this graph doesn't have any y values that are below 0. You have all your y values are above the x-axis. So pretty much if you made a t-chart, you're going to notice in that second column under the y's that you will have no negative numbers. So up here, you've got your range, which is all your y values will end up to be greater than or equal to 0. In our second example, we have a different function y equals 1 over x. Now they have what we call a domain restriction. And that is because you have a fraction. And remember, when you have a fraction, if you went 1 over 0, that 0 in that denominator makes that function undefined. In other words, it has no piece of the graph that exists when x is equal to 0. We'll deal with that in a second. So find the image of x is equal to 2. We're just plugging in y equals, look at our function, 1 divided by 2. And that's easy peasy. Now when you get to x is equal to -1/2, when you plug in 1 divided by -1/2, well, that looks crazy, right? I see that as a fraction divided by another fraction. I personally like to write them sideways, so 1 divided by -1/2, and if you'll remember how to divide fractions, you're going to change that to a multiplication problem and multiply by the reciprocal of your second fraction. -2 over 1, which is just -2. So y is equal to -2. And our domain. So our domain, our function is not defined at x is equal to 0, right? Because you get a undefined fraction when 0 is in the denominator. It doesn't exist. So our domain is all real numbers except for when x is equal to 0. Part C kind of flips the problem around, and it says decide whether y equals 0 is an element of the range. Justify your decision. Pretty much what you're looking at is you're asking yourself, can 0 equal 1 over x? Is that even possible? Think about that. The way I see it is no. And it's because there's no input that will produce an output of 0. So if you cross multiplied here, you would have 0 times x is 0, and then you would have 0 is equal to 1, right? So 0 times x, is that equal to 1? And no, that's not even possible. So 0 is not in the domain, or sorry, in the range. And that is because no input will produce an output of 0. Okay. In part D, we're going to decide whether y equals -5 is an element of the range and justify our decision. So similar to part C, you're going to ask yourself, can -5 equal 1 over x? And you're going to see when you cross multiply that, you can solve for an x value. You get -5x is equal to 1. So your x would have to be negative 1 over 5 in order for that statement to be true. So we're going to cross multiply. And solve for x. So x is equal to. This talking about function leads us to a new notation that we can use. So function notation, which you should have seen in Algebra 2, you've got y equals f of x. You're just taking the y value and replacing it with f of x. So it's just the function defined at x. This means that the image of x through the function of f is y. And of course, the x is the independent variable and y is the dependent variable. So for our example, it's similar. We're doing the same process as the last couple of examples, but now you know, based on the notation, that f of x is a function. So for every x, there's only one y value that corresponds to it. So we're going to find the image of x is equal to negative 2. So anytime you see an x, you're going to replace it with negative 2. So f, the function defined when x equals negative 2 would just be negative multiplied by negative 2 squared plus 3 times negative 2. Now, be very careful. Order of operations, you have to do the exponents first before you multiply by that negative on the outside. Oops. So a negative 2 squared is positive 4, so that becomes a negative 4 plus a 3 times negative 2 is a negative 6. So you get f of x, or f of negative 2, is equal to negative 10. And just another quick little one, we've got f of 1. So f at 1 is equal to negative multiplied by 1 squared plus 3 times 1. Simplify it down. You get negative, again, order of operations, you have to do 1 squared, which is 1, multiplied by the negative. So that would be a negative 1 plus 3 gives you positive 2. So f of 1 is equal to positive 2. And we're going to take it a little step further and show that the point 4, negative 4 lies on the graph of f. Now think back to Algebra 1. How do you know if a point lies on a graph? Well, you plug in your x value and plug in your y value and see if that equation is actually true. So that's exactly what we're still doing here. So plug in x is equal to 4, and then plug in f of x, which is our y value, equal to negative 4 into the equation to see if it's true. So if it's true, that point lies on the graph. If it's untrue, then the point does not lie on the graph. So f of x is equal to, here's our function again. Plug in what you know. Does negative 4 equal negative? Plug in the positive 4 as your x value, squared plus 3 times 4. Is that true? Does negative 4 equal negative 16 plus 12? That sure does. So negative 4 is equal to 4. That is true. True equation. So we know the point. Oops. 4, negative 4 lies on the graph. So if you found that equation to not be true, then the point does not lie on the graph. All right, so that completes this lesson. Now you can do 4B and 4D.